Okay, so I'm going to replace all the audio I originally recorded in this with voiceovers just because it's the first video I ever did and there's a whole lot of talking about nonsense. Like right now, like why am I even telling you this? Okay, so here is the pouch cell battery that I made for my Razer SX500 build. I recently did a video on that and recently sold it, but I wanted to go through this pouch cell battery pack because pouch cells are an extremely good value especially for how much power they can put out per, I guess, dollar, if you want to put it that way. I don't have the exact numbers in front of me, but this is a 48 volt 16 amp hour battery capable of 22 kilowatts, so 22,000 watts output. In my case, it's only 5 kilowatts because my BMS is a 100 amp, so it's limited to 50-ish volts times 100 amps, 5,000 watts. But even that, even 100 amp for the price I paid for this is pretty stellar, which I'll just put all that info on the screen. So what you're seeing now is, I guess, sort of the top that shows the bus bars, the spacers in between the cells, the series cells that is, and how I wired up some of the balance connections, and also showing the black spacers that hold the cells. So a really cool feature of this particular battery is these spacers. The cells just fit into there, and then you can sandwich them together, and they just fit like Legos. And then you can take that bolt, like I showed before, and screw it in, and that acts as the compression device for pouch cells. Pouch cells need to be compressed. I can't speak scientifically as to why that is, but they need to be compressed if you're going to be running them in high power loads like we are here. Maybe anytime you run them in series, I really don't know. But rather than having to use, like, say, some blocks of wood and some bolts, the spacers take care of that for you. But they also take up a lot of room. So if you need to save room, you might just forego the spacers and slap the cells together and find another way to compress them, which is also really common. Nothing really to worry about there. Of course, depending on your use case, you might still need to put them inside some sort of enclosure. So just something to keep in mind, but you can save quite a bit of space without using the black spacers. So now a little bit about the BMS, JBD SP22S003, 100 amp with Bluetooth. Got it from AliExpress for, 45 bucks. Great BMS, seems to have been working flawlessly, but I did run into a wiring issue that I wanted to talk about. I'm not sure if this issue affects all of these models, or maybe I just got a strange one. But basically the issue is that the balance leads on this second connector here, one of them is missing. So when you're looking at the wiring diagram provided by JBD, that's not the case. It shows all of the wires are there and all of the connectors. So that threw me for a loop. Especially being a newer battery builder, I want to make sure that I've got everything right. So I did a ton of research and really came up with no answers until eventually I stumbled on a fairly old, couple-year-old forum post where someone had the same issue, and someone in that forum helped them come up with a solution, which is to actually solder another wire on the BMS board itself where the missing lead would go. So now the BMS just thinks there is a lead there, and you can continue to wire it up just like you would according to the diagram. So just treat that new lead that you've soldered as the one that would be in the position on the wiring harness, which I think in my case for a 13S I just had to short all of them from like 12 or 13 all the way up to 22. So that's how you can fix that if you run into that issue. If you have any questions, just let me know. Alright, so next we can talk about the bus bars. So what I've done here is I've bought the bus bars, I think they're 4P or 6P from Battery Hookup, specifically designed for these cells, and I have cut them down into a 1P config. And this means I needed to create new spacers. So the orange things you see there in the video act as sort of like an insulation between the series cells so that you don't drop a tool and make a short. And when you buy these cells, not always, but mine came with spacers, but they were specifically for the 6P bus bar, and so they were just a little bit too thick for the 1P. I think maybe if you cut these bus bars in like the perfect way, you could probably get away with using the spacers that come with it. I didn't, so I ended up just 3D printing my own out of PTG. It's a very easy design, so I just whipped them up in Tinkercad and printed my own. So why don't we go ahead and take a look at how I cut the bus bars. I used this cool angle grinder jig because I didn't have like a miter saw with a metal cutting blade or a chop saw. So I got this jig that holds an angle grinder and lets you do perfect, miter style cuts. I shot this video cutting the bus bars in wide angle, so it's going to look a little weird, but I'll go ahead and put that on here. And here is the angle grinder jig I was referring to. So you can see it's got, front to back motion, up and down motion, a clamp for your work, the little cutout for the blade to go when you push down. You can adjust it pretty well, and it does need adjustment. You can't just screw it on and hope that your cuts are going to be straight. So it's a little trial and error, but not hard to do. And it's fairly lightweight, it's a cheapo $40 situation, but it did the job really well. My first few cuts were not so clean, so straight, and then I did some adjustments and was good to go. So highly recommend this for cutting thinner sheets. I'm not sure what size angle grinders it supports. Mine is a standard, whatever, 4.5, 5.25, I don't know. So here I go making a cut. So in this case, since the piece is so long, I have to work it back and forth, and also just trying to make sure it's a clean cut. Say a prayer for the little computer speaker in the background, which is still working just fine. I don't care about any of those electronics. That's why they're in the garage. So yeah, just making some cuts here. This is me trying to fill the time while this is going until it's completed, so I can show you the cut. Oh, there we go. Turn that sucker off, let it rest. Also, it does come with a blade guard. I took it off because it was getting in my way. Don't do that, use the blade guard. Alright, so here's the piece. As you can see, it's a nice straight cut. As you would expect, there's some burrs and stuff, but we'll clean that up with a Dremel. But overall, for $40 without having to go buy a miter saw and a metal blade, blah blah blah, I was really happy with it, and it really worked. It may be a kind of a niche thing, but if you cut, I think maybe up to 6-inch, wide pieces of metal, I guess wood, whatever, I think it's a good investment. Alright, so now let's take our messy bus bar and just hit it with the Dremel real quick and get rid of all those sharp edges. Alright, so now that we have our bus bars cut, I can show you how I've installed them. And you can see that it fits just between those two orange spacers. I think I printed those in PETG to hopefully withstand heat better. With the spacers that were included with the black cell holders, they were just too thick, so the bus bars wouldn't have fit in between them. So anyway, I've just used ring terminals here for the balance wires, which, I mean, you could solder them, but I had a bunch of ring terminals, and why not? I think I actually soldered the balance wire to the ring terminal as well as crimped it, or maybe I didn't crimp them at all. I'm not entirely sure, but I know at one point I noticed that if the solder was too far up, that when I tightened down the bolt, it would actually break it. So just make sure you solder it farther down on the ring terminal, and you should be good to go. So here I am installing the final balance lead. You'll notice that this one is comprised of like 6 wires, and that is because the BMS is adjustable for your number of series strings. I think it goes from 7 to 21. In my case, I'm doing 13 series, so I take the remaining, let's say 8, and I short them together, and I hook them up to the total battery positive. At least I think it's total battery positive, don't quote me on that. It may be cell group 12 negative. Anyway, the JBD or instructions will show you how to do that. It took me a while to figure it out for some reason, but I think now the documentation is much better. So yeah, hooking up the final balance lead here, and then I'm gonna go ahead and check all of the voltages for each cell using the balance lead wiring harness thing. So basically you can just insert your probes into the positive and negatives of the plastic wiring harness that connects to the BMS, and you can go through and measure each cell, make sure it looks good. You can measure in between cells, you can measure total battery voltage at the end, and just make sure everything looks good. So now that all the bus bars are wired up, balance wires are connected, we can wire up the BMS. I don't know if this is wired up, you know, in a final state, how I'm going to have it when it's done. I don't remember. I think maybe I'm just wiring up the BMS to make sure everything works. But here it is. As you can see, it's got 2 wires for C minus, 2 for B minus, because it's a 100 amp BMS. I think anything less than like 50 may just have a single wire. But you're going to want to whenever if you're pulling close to 100 amps. It looks like I'm using XT90 connectors. So C minus is the negative that goes to the load and the charger, and the red wires are what go to battery positive on here. B minus is the balance negative, or just the total negative of the battery. So ring terminals on those, that'll go to the total negative, and then on the red wires for the total positive. So that'll give me my 48 volts. Alright, so now that battery negative is hooked up to the BMS and the battery, we can plug in the balance leads. I believe for JBD, BMS, maybe all of them, the order of operations is battery negative, then balance leads, and then battery positive. So hook up your balance leads. Before you do battery positive, it would be a great idea to double check your string voltages. So, you know, check each balance lead, make sure it's showing the correct voltage. That way you don't hook it up and have some funky errors going on. Once you're done checking voltages, go ahead and hook up battery positive. And I think I'm only hooking one up right now, just so I can check total voltage and make sure everything is good. And then I'm going to install the JBD app on my phone. This particular BMS has Bluetooth capability. I would recommend that for any serious build, so that you can make sure that your cell groups are always in balance, for one, and two, just being able to see current, output, state of charge, all that fun stuff, editing parameters if you need to. So yeah, highly recommend the Bluetooth functionality. Okay, so make sure you get the app after you get your BMS going. The only way I think to configure it is either with the Bluetooth app or the UART port, whatever, blah, blah, blah. There's a couple quirks with the app that I just figured out, so I wanted to share. Firstly, make sure you provide or sign up for an account. So it'll prompt you to sign up for an account. It allows you to skip, but if you skip, you won't get access to a lot of these settings. So they force you to get an account, so just give them your burner email and go ahead. They don't even send you a confirmation email or anything. It's pretty painless. Next is when you, in my case, when I signed in here and opened the screen for the first time, it showed cells 1 through 11 and then cells 12 through 20, I think 1 were blank, and then it showed cell 22 and 23, which is how it's wired. So then you have to tell the app or the BMS, whatever, that how many cells you actually have, and to do that, I think is parameter, origin setting, and cell number here. Just change that to how many cells you've got, and assuming you've wired it correctly, when you go back to your main screen, it should show them. And it does, and it's showing voltage here, 50 total volts, 70% state of charge. So I just wanted to make sure when you get in here, you know how to do that shit. And here the battery is installed in the Razor, and by some miracle it fit right in there. Definitely check out the Razor video if you're into that.